A glow valve is generally seen for the very higher flows and HVAC mostly. So a glow valve are different from ball valve. Now many people have confusion, don't confuse. It's not a ball valve, it's a glow valve itself. Now how it will work, I'll show you. Is a type of valve used for regulating flow in a pipeline consisting of a movable disc type element and a stationary ring seat in a general spherical body. Now anyone has seen Swadesh, they can relate this easily. Yes, anyone? They can easily relate this. Yes or no? That scene, I think the moment I said you recalled it. How? There will be some clogging in that, some kind of grass or something. So he just go dip in that and he removes that. And again, he tries to generate electricity. The same kind of thing over here, I'm saying. It's a glow valve over there. He opens it and you know this. The water goes in this manner. The water enters here in this manner. It goes, first of all, it has been stayed over here. The moment I rotate this, as you can see, the stem, the cylindrical sphere body, the moment I rotate, this will be lifting up and up and up, and the more upper, the full, like example, I've opened completely up, the complete, for example, 10 GPM, I will be getting almost the 10 GPM on the other hand side. So this is a regulating valve. That means I can adjust the flow as per my requirement. Example, I have a pressure gauge at the outlet and I need a pressure of 10 psi. If I'm getting 20 psi, I can adjust by pressing this. I mean opening or closing. I mean rotating in clockwise, or opening, or anti-clockwise for the closing, or counterclockwise. So I can, I mean to say is I can regulate the flow as per my requirement. Okay, so this is generally a regulation flow, a regulating valve. Let's look at an angle valve. Yesterday I have said you, a gate valve works on the principal tap, isn't it? Now angle valve works in which thing? No, angle valve works in what? Yesterday I said you, angle. I have said you about the taps. First of all, I said you water taps, underwater taps. We have seen 2 to 3 taps. For, for faucet, right? Faucet. So this works because in faucet, if you see, we do have a mechanism of angle valve inside. Because generally, now you will be relating this easily, and you can relate with the faucet also. You'll be getting the concept. Now this angle valves will be generally and commonly seen below the laboratories because not air bubbles. That is faucet. I'm talking about an angle valve. Now, angle valve is a valve. Again, it is also a very small valve, but it is a regulating valve. Why? Because I'll say you, this is not directly being connected to the faucet. That's why we do have an angle valve below the laboratories. Because if I do get excess pressure, for example, if it's a G+6 building and I'm using this at the second floor laboratory, I'll be getting a very huge pressure. And I know that, for example, a laboratory demands 8 psi, for example, I'm saying, but if I'm getting 18 psi or 10 psi or 12 psi, what happens online? Anyone? What happens? The the fixture will be getting damaged for sure because of excess pressure. And what happens when you compare with angle valve and faucet? That fittings are very expensive. Hmm. This is very, when compared with that, this is reasonable or feasible. We can afford this. That is one time investment kind of thing. Or no, not, I can't say, but it's a matter of like cost saving you're doing this or cost cutting. So what happens? We do have this. So what happens if excess pressure? This will be first getting damaged. After that, what? Because it is blocking the water before entering to the faucet, isn't it? So we'll be adjusting the flow as per I need, and that much is pressure is not at all recommended or not at all required also, because that's so much of pressure if I'm getting, the moment I'm opening faucet, it is flashes out when it hits to the laboratory, and what? My clothes will be getting disturbed, or some other people standing beside me will be getting disturbed, isn't it? So that's why we do have mostly angle valves over there. Same kind of thing faucet has, because of what? Again, inbuilt we have in faucets. Inbuilt. Generally, why we do have this angle valves? Because we don't have faucets. What we do have? Mostly kind of taps. It looks good in interior, but it is not a faucet, because if it is a faucet, then there is no need of angle valve, because inbuilt we do have this. As I said yesterday, because faucet works on principle of angle valve, and the taps gate valve. Now, now let's proceed with the PRV. Now we are entering slowly into the uh, designing concepts or designing steps. Now PRV stands for pressure reducing valve. Now what do you mean by this? The word itself It's been saying that this is a valve which is here to reduce the pressure. Now, how and where and why and how come the pressure is being increased or where it should be installed and all this. Let me tell you something about this. Now, this valve is a valve. Generally, you'll be seeing this in the high-rise buildings, first of all, where very big buildings, because in high-rise buildings, for example, I'm having a transfer pump and I'm having a tank at the 30th floor. Okay, for example, 30 floors means I'll be having all 30 floors. For example, I'm having a tank at 30 floor and the water is coming from the tank 30, 29 till the first floor. Now, I have thrown one stone. I've dropped one stone from 30 floors of building. Now, just say me the velocity or just say me the weight or velocity I can refer you over here. As the stone is getting below and below, the velocity increases or no? Same kind of thing what happens over here. As the water is coming from the 30 floors, it will be coming 30, 29, the pressure is increasing and increasing and increasing and keep on increasing. And I'll be getting so huge pressure that which is not at all recommended as per the standards and codes. And that code is IPC and UPC, which we do follow. Anish, I think you know this. Anish, what is the value where you have a pressure reducing valve as because you use UPC, 60 psi? And as per IPC, it has been recommended from International Plumbing Code, if you have a pressure in a riser or, okay, because in riser, in water main, that is riser. So in risers only you'll be seeing this. You'll not be seeing inline or within the line or within this floors and all this. You'll not be seeing pressure reducing valve because where is the main source? From where? Because of the gravity only the pressure will be increasing. So I'm cutting at that moment only. So no doubt I'm maintaining a pressure which is said by the standards or codes, that is as per IPC and UPC. I'll tell you, I'll do an example also right now. Just first of all, let's see how it looks like and where it has been installed. I said you, and why it is installed, because to maintain the pressure in line less than 60 psi or 80 psi, and always remember it is only and only installed in the risers and within a high-rise buildings. Because where I do know this, okay, for sure, don't you people think the water is coming from 30 floors of building? When it reaches to the ground floor, do you people think it crosses to 60 or 80 psi? Will it or no? Yes, online. For sure. It will be like almost 300 psi something, which is not at all recommended, because we know this as per some table number, as per IPC, we got to know that it is a standard pressure and GPM, which every fixture demands. If I get more than that, the fixture will be getting damaged. Not only fixture, because of excess pressure, what are the things? Leakages will be happening. And for example, I have done a solvent welding and all this, it will leak because of excess pressure, isn't it? So leakages might happen and water hammering will be there. We'll be discussing this later. And what happens? Leakages, water hammering, and excess pressure will damage this reduce the life of the pipes also, because excess pressure. Because if you see the pipe online, as per ASTM or something, they'll be written some PSIs also. Have you observed this online? On any kind of pipe, take any kind of pipe, UPVC, CPVC, on any site of the plumbing. Have you seen? Okay. Or else check in our household only, in the risers, they'll be written something PSI. That is what? That means this pipe can bear this much of pressure only, not more than that. If it is more than that, it will bust. Have a pressure exerted at the bottom formula. What is I'm right now about to find out. The formula is P is equals to H into 0.443 psi. I'll say what is pressure exerted. That you will be one column of water. What you are saying is you will be reading in terms of firefighting in Switzer. Okay, we'll be doing one experimental thing, that is pneumatical formula he'll be dealing with. Okay, and now you can relate, just understand, I am here to what, just to calculate what would be the weight at this pressure, with this pressure at this height, and that is a constant 0.433 psi. I'll be getting, I'm here to right now do that only. Okay, Anish, and one liquid column of height, that is what, 300 something, what you studied in firefighting. Okay, don't worry, you will be again seeing this in terms of firefighting. Pneumatical formula, sir will be dealing in detail. Yes, I was saying it is used to reduce the pressure in order to reduce the maintain or the life of the pipe. The valve reduces the pressure of the water that goes through it. That, as Jasna said you, the valve reduces the pressure of the water that goes through it, and is used to obtain a regulated and constant value at its outlets. That is a standard value, what I'm going to say you now. It is installed at the water mains, nothing but a riser for the high-rise buildings. It protects the whole installation from problems due to excess pressure, noises in the pipes will occurring, water hammering and splashes, as we have discussed. Now, as per IPC, if you search in IPC, it's been clearly said that 80 psi. If you have an 80 psi, if you have this, there should be one water hammer arrestor. It has been clearly said over there. Now, as per UPC, they believe this. If in the main riser or water main, if the pressure is exceeding more than 60 psi, there should be one pressure reducing valve installed over there. And how it exactly looks like, a kind of spring and all this. So what happens, more pressure, it compresses the spring and all this, it reduces, and the again, okay. So just first of all see this, there's basement 2, basement 2, basement 1, ground, first, second and all this. This is what 14 floors over here, as you can see. Then again it's continuing, and from 14, 15 and all this, it goes on to 30 floor. Then on the upper roof and higher roof, I'm having a tank over here, and from this tank, as you can see, there is a water coming down. As you can see, this is directly coming down over here, and I'm having is one PRV. This is spring and all this, isn't it? So water goes in this way, okay, and reduces. Then again, it will be 0 psi from this point. So I'm here to really interested to find, as I got some information now. This, as per IPC and UPC, they have been saying the codes that if the pressure in the main riser or the main thing over here, water main, if it is exceeds more than 60 or 80 psi, they are been saying that I need one PRV to be installed over there in the water main. Now let me find out what kind of standard they were following over here. Now how I can find out? It's very easy. First of all, let me do one thing. Let me measure this distance, because from here the gravity force will be acting. This is not a gravity force, this is horizontal. In vertical it will be acting. So this water is coming down in this manner. Agree with me online classroom? Okay. Right now I'm just about to just learn over here. Okay, this is a PRV location. I clicked it over here. How much the value? Just note it down online. 40,170.75. This is in terms of what? Can anyone say? 40,170.75. Or yes, very good. Now, I have a formula in firefighting. You'll be selecting that pressure exerted at the bottom. That means the pressure here, the pressure over here, because it will be having a pressure, because as the gravity is increasing, the water pressure will be increasing more and more, more and more, more and more, isn't it? So I need to calculate the pressure where I'm getting a pressure of 60 psi or 80 psi. I need to know that. So I do have a formula to calculate this, that is P is equals to H into 0.433 psi, where P is the pressure, where I need to find out, that is nothing but the pressure exerted at the bottom. Okay. And H is what? The height. H is height, and it should be in terms of feet. Write down where H should be in terms of feet. It should be in terms of feet, units. Okay, and 0.433 is constant. 0.433. Okay, and P is what? The pressure exerted at the bottom, because I need to know that only. Because if the pressure exerted at the bottom means what? Here I'm saying this point, if it is crossing 60 or 80, then for sure I'll be having is what? One PRV over there. So I got a value. Now as per this project, they have installed over here. Now let me check what standard they were following. I can prove this now. So I have a value of this 40170.75. Can anyone convert this to feet? How you will be doing this? No. How can you do this? First of all, this is millimeters. 1 meter is how much? 1,000. So first of all, divide this and convert this to meters. So 417, I'll say you 1 minute online. 130. Very good. 40170.7502. This is the value. Whole divided by 1,000. This is in terms of meters. And 1 meter is equals to 3.28 3.28 feet. So I need to divide, multiply or what? First of all. Very good. So times 3.28. I got this in terms of feet. Now put this in formula. P is equals to 131.76000060 or something like that into 0.433 I'll be getting in terms of PSI. This is 57.05. So what standard they are following online? Yes, online? Yes, very good. UPC. Hmm. Yes, very good. UPC. So now one more thing I'll say you. As you see over here, this is from the 30 floors. On the 25th floor only I got a 60 PSI. There are more 24 floors remaining apart from basements too. So don't you people think we need one more PRV? Yes, for sure. When it is in 6th floor, I'm getting this much. I'll be having one more PRV over here. Not only one more, I am having total number of 4 PRVs in the complete project. From here, I can say from the 6th floor to the basement, I'm not having any PRV because it's not exceeding more than 60 PSI or 60 is also accepted. They have taken as a safety factor. They might have installed here also. But I think if they were calculating over here, it might be increasing more than 64, 61, 62. That's why they have installed in this floor. Now let's do one more. Shall we online? Be kind of zero. It will be zero over here because here is 60. It will be blocking this and the things. Now just see example. I'm having a branch over here. So in order why we are maintaining this because as per this codes it has been clearly mentioned from the code if we do have a 60 or 80 psi as per the respective codes, if I maintain this in line, I mean in the main riser, I'll be getting the required amount of sufficient amount of I can say pressure which performs to work in a very proper manner to all the fixtures. It should not cross more than that because it is beyond that because generally and commonly the fixtures what we see over here or what if you see over your IPC or UPC it will be in the range of 8 psi to 20 psi, not more than that. Have anyone checked this or anyone has any idea? This is the range of all the fixtures of the complete plumbing. It does not require more than 8 to 25. So why I'm fixing the 60 because I'm not only considering for one floor, I'm considering for the n number of floors. And we know this, that only one floor will not be. Okay, might be this people will be also calling for water, or this people, this people, this people, anyone. But not all the fixtures, but anything, something will be going on in every floor, isn't it? Like washroom, like kitchen area, like shower, different applications it might be in the different floors, isn't it? So to avoid all this, it is a standard they are saying that it should not cross more than 60 or 80 psi. Okay, so here as you asked, here everything will be zero because it has reduced the speed. It has stopped that velocity, it has consumed it by means of spring. It tries to compress this. That energy is being converted into this, compressing this or pressing the spring. Okay, that became completely zero. And again, the water is going down. Again, according to me, this might be 60 psi or nearby 60 or exact 60. They have been one more psi. Oh, sorry, PRV. So let's do this also. So for example, I'll be using this again, DI command for the distance. Let's measure from this PRV to this PRV. This is what your question is, right, Mudassir? So let's do this, Mudassir. 42254.30 mm. Convert this to meters, convert this to meters to feet, multiply 0.433. Okay, so I think now Mudassir, you have cleared your doubt because it was zero for sure over there. So that's why the moment here is 60, I have one more PSI. Still it goes on Mudassir because we do have n number of flows now because I have seen according to my experience if I'm seeing in a logical manner on every sixth floor I'm getting almost a 60 PSI. That means each floor demands 10 PSI of water because of the gravitation pull. It's not standard. Don't fix that. I'm saying that. Okay. So that's what we do have n number of PRVs. It might be 2, 3, 4, 5 as the number of building. That's why I said to you, PRV is mostly seen in the high-rise buildings because we know this. The moment the more higher building, if I'm having a water coming down straight away from the tank, it'll be huge pressure because of gravity pressure. Because if it increases the height, the gravity force also increases, isn't it? It comes with so much of force. So I need to block that because as per the code, it's not been recommended to enter the water more than the 60 psi or 80 psi. The psi is, you know, this units of pressure, not at all recommended. And I said you 8 to 25 psi is the standard, or the pictures demands not more than this. 25 is for WC. Yes, it will be always. It's not only PRV. You need to have before this. You need to have for the maintenance purpose. You need to have this. So it will be a station only. I'm just talking about only this thing. This is only PRV. But this installed in this manner only. So this is a station then. No, because we don't. There is no use of what. There is no gravity force acting on it. Do you think so? Because in vertical pipes, isn't it?